Hello friends, in this video we'll learn how to mesh our structural members. Okay, so let us first see what the meshing actually is. Okay, so for example, if we mesh this slab over here, so it means that we divide this slab into a number of rectangles, right? Why we do that? It's because ETABS uses a finite element method, and for the loads on this slab to transfer realistically into the beam and the loads from the beam to realistically transfer into the column and to the footing, we have to mesh our structural members, okay, and convert them into a small number of rectangles, right? So let us first mesh our slab members. We first select all the slabs. Okay, so we go to properties and click on slab sections, and we select these two slab and staircase slab and click on select and click on close. Okay, so after that what we do, we go to assign and click on cell and click on floor auto mesh options. And here so there are two ways that you can mesh your structural members, and one is that you just select all your slabs and click on mesh the objects into 2 by 2. So 2 by 2 means that in this direction it will make two rectangles, so one rectangle, two rectangle, and in this direction as well it will make two rectangles, 1 2, so total of 1 2 3 and 4 rectangles. Okay, so here we'll use default option and we'll change this option over here. So we'll use rectangular mesh, and so size of the mesh is 0.5, let us take 0.5 meter. Okay, so lower the size, higher is the accuracy of calculations, but it will result in slowing of your software, right? Because it has to do a lot of calculations. We click on OK, and after that we click on apply. So make sure that you have checked this option over here, and we click on apply and we click on OK. So to see the mesh, let us go to this display and click on cell analysis mesh and click on apply and click on OK. So you can see that your slab has been converted into a number of mesh. Okay, so if you see this portion over here, this mesh line is not in line with this mesh line, right? So due to this reason there will be problem in the load transfer mechanism. Okay, so to override this problem, what we do is that we again select all the slab options over here and go to assign and click on cell and click on auto edge constraints, and we click on create auto edge constraint around walls and floors, and we click on apply and we click on OK. This is how we mesh our slabs. Now we mesh our frame structures as well. So for that, go to select and click on select and click on properties and click on frame sections and select beams and columns and click on select and click on close. So after that, go to assign and click on frame and click on frame auto mesh options and check this option over here, auto mesh at intermediate joints and intersecting frames and edges, and we click on apply and we click on OK. So after that, we again select all the frames and click on assign, click on frame and click on frame flooring mesh options, and we check this option over here and click on apply and we click on OK. Alright guys, so this is how you mesh your structural members in ETABS. Okay, so now that we have done a lot of things on ETABS, right? So there is a correction that we have to make. Okay, so let us go to the roof and let us remove these things, and let us go to the roof and let us not see our. Okay, so this is the roof now. So if you just right click on the slab, you can see that the loads applied here is a floor finish 0.5 kN per meter square, and the uniform load, live load less than or equal to 1.5 kN per meter square. Okay, so this load application seems correct, but it will give false results, because if you go to the mass source, right, so click on the mass source and click on modify so mass source. So you can see over here that you have to check only this option over here, and here for a live load less than or equal to 3, we have taken the multiplier as 0.25. So the first thing, why we need the mass source, right? So the mass source is used to calculate the seismic weight of the building. Okay, so seismic weight of the building is required to calculate the earthquake load on it. So earthquake load on it, right? Okay, so live load less than or equal to 0.25, it means that we only take 25% of the live load that is applied on the slab, because most of the people run away from the building when there is the earthquake, right? And for greater than 3, we take 50%, and for roof light here we have taken 0, because we assume that when there is earthquake there is no person on the roof, right? So here we have applied the load as the live less than or equal to 3. It will give us false results because it won't take that live load as 0 for applying the earthquake load. So what do we do? we select all these slabs and go to assign and click on uniform. And after that, we select live less than or equal to 3 and we click on delete existing loads and we click on apply. Right, so after that we click on previous selection and we click on roof live. Where is that? Roof live, and we replace it and we apply the roof live of 1.5 kilonewton per meter square and we click on apply. Okay, so now that while calculating the seismic weight of the building, the ETABS will take the roof live as 0. Okay, so this much for this video. Hope this video was helpful. See you in the next video.